Welcome to this video tutorial involving solving trig equations, likely by factoring and incorporating the unit circle. In these situations, the first thing that we want to do is get a 0 on one side of our equation and get everything else on the other side of our equation. So we're going to start by taking the right hand side of our equation over to the left hand side and getting an equals 0. Now we can either just think about how we might factor this expression, or we can think about maybe factoring by grouping. Each of those ways is going to have merit. So let's talk a little bit about factoring by grouping in this tutorial. If I group the first two terms together and the second two terms together, and we look at factoring out the greatest common factor, over here we could remove a 2 sine of x, leaving us with 2 cosine of x minus square root of 3 sine of x, or minus just square root of 3, actually. We already took out the sine of x. Now we want to build that same expression in the parentheses over for the green, what I've labeled in green. So we want to have a 2 cosine of x minus square root of 3. And we can actually get that by factoring out a square root of 3. Keep the equal 0 in our equation, please. Now they have this expression in common, the 2 cosine x minus square root of 3. So we'll factor that out front, and we're going to have 2 sine of x plus square root of 3 as the remaining portion of our set of parentheses. That comes from 2 sine of x is what remains after we take out that set of parentheses on the left, and radical 3 is what remains after we take out that set of parentheses on the right. Now we solve by setting each of these factors equal to 0. So 2 cosine of x is equal to square root of 3, which means cosine of x is equal to square root of 3 over 2. Let's go to our unit circle. For cosine of x to equal square root of 3 over 2, that means we want to find spots where the x coordinate is square root of 3 over 2. There's 2 of them on the unit circle, pi over 6 and 11 pi over 6. So when we write out the answers for that portion of our equation, we're going to say x is equal to pi over 6 and x is equal to 11 pi over 6. Those would be answers, but there could even be more answers. So we will set the other set of parentheses equal to 0 as well, which will give us that 2 sine of x is equal to a negative radical 3. So sine of x is equal to negative square root of 3 over 2. Go back to our unit circle. We want where the y coordinate is negative square root of 3 over 2. There's 2 spots where that occurs, 4 pi over 3 and 5 pi over 3. So we'll come back over here and we'll say that x is equal to 4 pi over 3 and x is equal to 5 pi over 3. For the purposes of where we are currently at with content, we're looking for all values greater than or equal to 0, less than or equal to 2 pi. That would be the extent of our first problem. We will consider one other problem, and that's the problem that is pictured on the screen right now. So let's go ahead and get everything on the left of our equation. Oops, that should be a 4x, not a 4. Minus sine of 2x minus tangent of 2x plus 1 equals 0. Again, if we factor by grouping, in these first two terms, we could factor out a sine of 2x, leaving us with a tangent of 4x minus 1. Again, that comes from taking just these terms right here and grouping them to factor out the sine of 2x. Then we would group the second items, keeping in mind that we want to build the same thing in the second set of parentheses. Ooh, I have a little mistake. Let me fix that up. That shouldn't be a 2x. Look back at the problem. That should be a 4x. So then we're going to have a minus, factor out the minus sign, tangent of 4x minus 1. Okay, so that's where we're at. Now those expressions have the tangent of 4x minus 1 in common, and then it will leave us with the sign of 2x minus 1 from the remainder. In other words, once we take away the parenthesis on the left, we're left with the sign of 2x. Once we take away the parenthesis on the right, we're left with just the minus 1. And now we set each of those things equal to 0. Setting it equal to 0 gives us the tangent of 4x is equal to 1, which means 4x, we're going to have to go to our unit circle. Where is tangent equal to 1? Well, tangent, which is y divided by x, equals 1 when the x and the y coordinates are the same. So it's going to be at pi over 4 and 5 pi over 4, where that's true. So let's come back over here. 4x is equal to pi over 4, and 4x is equal to 5 pi over 4. But be careful. Now this is where things get a little bit dicey. So if we divide by 4, we're going to get that x is equal to pi over 16 on the one hand, boop, and we're going to get that x is equal to 5 pi over 16 on the other hand. But remember what we've said before, that when we add multiples of 2 pi, we get coterminal angles. Well, here we're dividing by 4, so now when we add multiples of pi over 2, we are going to get coterminal angles. So we're going to go through and keep adding pi over 2 until we get up to 2 pi. Now pi over 2 is really 8 pi over 16. So what I'm going to look to do is add 8 pi to the numerator. Okay, so we're adding 8 pi over 16. We are going to add 8 to the numerator. So pi over 16, we'd have 9 pi over 16. We'd have 17 pi over 16. We'd have 25 pi over 16, but now be careful because 33 pi over 16 would be bigger than 2 pi. We're just writing out the answers that are going to be between 0 and 2 pi inclusive. And over on the right, as I add 8 pi over 16, we'll get 13 pi over 16, followed by 21 pi over 16, followed by 29 pi over 16. All of those answers are going to work. So far we have 8 answers. Those come from the fact that the tangent of 4x is going to be equal to 1. But that's not all. We've got more solutions that are going to be popping up because we also have that the sine of 2x minus 1 equals 0. Setting that factor equal to 0 tells us that the sine of 2x is going to have to equal 1. So we want the y coordinate to equal 1. Go back to our unit circle. The y coordinate equals 1 up here when our value of theta is pi over 2. So we know that the 2x is going to equal pi over 2. There's just the one solution here. Divide by 2 and we get that x is pi over 4. But like we said in this other portion, normally 2 pi is what we would continue to add to get coterminal angles. But here we're dividing by 2, so now we're going to be adding pi to get coterminal angles. Pi is really 4 pi over 4. So we will add 4 to the numerator. We'll get 5 pi over 4. And then 9 pi over 4 is going to be bigger than 2 pi. We just want answers between 0 and 2 pi right now. Those two would be additional solutions. So we just want to go through, solve the factoring problem by likely factoring by grouping or finding some means to factor it, setting each factor equal to 0, and interpreting the unit circle correctly.